Hi everyone, in this video I want to talk to you about how to do a quadratic regression for real life problems. Okay, so in class we discussed how to find a regression, like the answer itself, and then how do you apply this to a real life problem and how do you answer questions about a quadratic that deals with real life situations. So in my screen, I'm actually going to be solving problem number 1 and number 2 from the review. Okay, so if you have questions on number 1 and number 2 on the review, check this out. I'm about to show you. On the Desmos calculator, I have a template that you have access to. Okay, this template is found in Schoology in today's folder. On the review day of the folder, you can click on quadratic regression template and it'll give you the formulas, it'll give you the table, it'll give you all of that stuff. Okay, you just have to go to the folder and click on quadratic regressions template. Let's begin. Whenever you find a quadratic regression, you need 3 points from a table to construct an equation. So I have 7 points here. I just need 3. So I'm going to type in 0, 70, 1, 184, and 2, 266. By adding this right here, notice how these two equations, this is the one in standard form with ax squared plus bx plus c, and in vertex form, now I have solutions. I have my answers that I'm looking for right here. And these are actually going to be used for your answer, right? So this one's looking for a, b, and c, so I'm going to type in the values, negative 16. Second one is 130, and the last one is 70. Those are the A, B, and C values that you see right here in this section. If the question was in vertex form, I would have put A, H, and K as my solutions. Okay, now let's go to question number 2. This is just making the equations. Now that we have the graph, I can actually answer questions about this graph. And these are the questions that I'm really interested in answering. I want to know, what is the initial height of the rocket? What is the initial height of the rocket after, or is the height of the rocket after 2.7 seconds? After 7.6 seconds, like where do I find this rocket that we're dealing with? And then when does it hit the ground? All of that kind of stuff. So all of these can come from this graph. I'm going to reduce the screen a little bit on the left, add some space. If I zoom out, I can see the equation right here, right? There's this big parabola that's popping up. This is my parabola because it's a rocket. It goes really, really high and then it comes down. So what is the initial height of the rocket? The initial height, now when you're looking at this parabola right here, we're never going to be dealing with like negative stuff with real life situations. So there's never going to be negatives and nothing over here as well. We're not going to go below the ground for rocket. It's going to start at 0. So we can actually zoom in and just ignore the negatives and focus on the top, the positives. The initial height will always happen at the origin, or sorry, better explanation, it'll always happen at 0. So I go to 0 and I go up to the y-axis. This is the beginning. The y-intercept at 0, when time is 0, 70 is the initial height of the rocket. Remember, anything below that on the left is the negative numbers. None of those numbers matter. Like negative 0.2, negative, we don't have negative time, right? We don't have negative distances, so we're not going to worry about that. We start here at 0. That's what we want to know. So the initial height of the rocket when time is 0 is 70 feet. What is the height of the rocket at 2.7 seconds after being launched? Now, if you look at the previous problem, height, let me go down here a little bit to the previous problem. Height was considered the y value, right? And time was considered the seconds. So seconds is x and feet is y. We are interested for this question, we want to know, when is x going to equal 2.7 seconds? When is x going to equal 2.7 seconds? That's what I want to find out. So when I put it in here, I can actually type in x equals 2.7. And wherever this new line that popped up, this blue line, wherever it crosses the y, the graph, that's how I know where my answer is going to be. The rocket is going to be after almost 3 seconds, the rocket is going to be somewhere up there. So let's move up a little bit. Let's move the parabola. All I have to do is drag this. so I can get closer to where I can see it. See how it's about to cross it? It's going to cross it somewhere in there. Now all I have to do is press the line. When you click on the line, you see this gray dot that appeared? That gray dot is the intersection. That's my answer. So after 2.7 seconds, the rocket is 304.36 feet in the air. And that's my answer, 304.36 feet in the air. What is the height of the rocket after 7.6 seconds? Same thing. We can go in here and instead of saying when x is 2.7, we can say when x equals 7.6. Now the blue line's over here. We want to figure out where does it intersect, right? We want to figure out this intersection point. It's going to be somewhere in there. So I click on the line. You see this gray dot right here that appeared? Boom, click on that. After 7.6 seconds, the rocket is now 133.84 feet in the air. And that's my next answer. Next, after how many seconds will the rocket be exactly 150 feet? Notice how now you're not given seconds. Here, this problem was in seconds, right? Because in seconds, that's the x-axis or the x value. This is now feet. Feet is the y value. So I'm going to change my equation. Instead of saying when does x equal something, now I'm going to say when does y equal 150? Now the line changes to be horizontal instead of vertical, right? Because now we're dealing with the y variable from your table. And if you look here, we zoom out a little bit, it crosses the parabola twice. When I click on the line, I see two gray dots appear here and here, and those are my solutions. When is the graph going to be 150 feet? At 0.671 and at 7.454. 0.671. You want to put the 0 for this problem just to count it correctly because it gets very specific. If you don't put the 0, it counts it wrong. So put 0.671, 7.454. The next one is, after how many seconds will the rocket hit the ground? For this one, I don't really have to put in an equation. The ground is considered the x-axis because we're never going to go below the ground. So the x-axis is where it's 0 at. The x-axis is at here and here. Those are my two x-intercepts. Okay? Now, does it make sense for the rocket to hit the ground at negative seconds or at positive seconds? Positive. This is where it starts and this is where it finishes. So after how many seconds will that rocket hit the ground? After 8.632. This point over here is irrelevant. This is our solution. So after 8.632 seconds, the rocket will eventually hit the ground. And then lastly, what is the maximum height of the rocket? Well, the maximum height is always going to be at the vertex, the peak. So if I zoom out, the peak is right up here. When I click on the vertex, the maximum height is 334.062. It's not this one because remember, x represents seconds. This is how many seconds it takes to hit the maximum level. This is the actual maximum height. As long as you remember the variable that x represents time and y represents seconds from your table from the previous problem, you should be okay. So 334.062. And that is the maximum height of the rocket. All of these questions can be answered on Desmos if you understand what the variables mean, right? If you understand that the x-axis is time, the x variable is time, and the height is the y variable, then you understand which number to pick. So to quick recap, the initial height of a rocket is going to be found in the y-intercept. When does the rocket hit the ground? Those are the x-intercepts, right? When does the rocket hit the ground? That's the x-intercept. And then what is the maximum height? This one is the vertex. All right, guys, I hope this helps. I can even label them here for you if you want as an extra set of notes. The initial height will always be the y-intercept. Y-int. I can't seem to write it because the formula changes. the y-intercept. I don't know what's happening here. So the initial height is the y-intercept. So 0, 0, comma something. The maximum height is the vertex. And when does it hit the floor? At the x-intercepts. So at 0, comma number, and the other one 0, comma number. The x-intercepts is when it hits the floor. The max height is the vertex, and the initial height is the y-intercept. Hope you guys have a great day. I hope this helps. And in preparing for your exam and your final exam, you guys have a great day. And as always, our calculator.